In this video, we're going to get introduced to the Pythagorean theorem. Pythagorean theorem, which is fun on its own, but you'll see as you learn more and more mathematics, it's one of those cornerstone theorems of really all of math. It's useful in geometry. It's kind of the backbone of trigonometry. You're also going to use it to calculate distances between points. So it's a good thing to really make sure we know well. So enough talk on my end. Let me tell you what the Pythagorean theorem is. So if we have a triangle, and the triangle has to be a right triangle. So it has to be a right triangle, which means that one of the three angles in the triangle have to be 90 degrees. And you specify that it's 90 degrees by drawing that little box right there. So that right there is, let me do this in a different color. That right there is a 90 degree angle, or we could call it a right angle. And a triangle that has a right angle in it is called a right triangle. So this is called a right triangle. Now, with the Pythagorean theorem, if we know two sides of a right triangle, we can always figure out the third side. And before I show you how to do that, let me give you one more piece of terminology. The longest side of a Pythagorean of a right triangle is the side opposite the 90 degree angle, or opposite the right angle. So in this case, it is this side right here. This is the longest side. The way to figure out where that right triangle is, and it opens into that longest side. That longest side is called the hypotenuse. And it's good to know because we'll keep referring to it. And just so we always are good at identifying the hypotenuse, let me draw a couple of more right triangles. So let's say I have a triangle that looks like that. A triangle that looks, let me draw it a little bit nicer. So let's say I have a triangle that looks like that. And I were to tell you that this angle right here is 90 degrees. In this situation, this is the hypotenuse because it is opposite the 90 degree angle. It is the longest side. Let me do one more, just so that we're good at recognizing the hypotenuse. So let's say that that is my triangle, and this is the 90 degree angle right there. And I think you know how to do this already. You go right, what it opens into, that is the hypotenuse. That is the longest side. The longest side. So that is the hypotenuse. So once you have identified the hypotenuse, and let's say that that has length c, and now we're going to learn what the Pythagorean theorem tells us. So let's say that c is equal to the length of the hypotenuse. So let's call this c. That side is c. Let's call this side right over here. Let's call this side right over here a. And let's call this side over here b. So the Pythagorean theorem tells us that a squared, so one of the shorter sides, the length of one of the shorter sides squared, plus the length of the other shorter side squared, is going to be equal to the length of the hypotenuse squared. Now, let's do that with an actual problem, and you'll see that it's actually not so bad. So let's say that I have a triangle that looks like this. Let me draw it. Let's say that this is my triangle. Looks something like this. And let's say that they tell us that this is the right angle, that this length right here, let me do this in different colors, this length right here is 3, and that this length right here is 4. And they want us to figure out that length right there. Now, the first thing you want to do before you even apply the Pythagorean theorem is to make sure you have your hypotenuse straight. You make sure you know what you're solving for. And in this circumstance, we're solving for the hypotenuse. And we know that because this side over here, it is the side opposite the right angle. If we look at the Pythagorean theorem, this is c. This is the longest side. So now we're ready to apply. We're ready to apply the Pythagorean theorem. It tells us that 4 squared, one of the shorter sides, plus 3 squared, the square of another of the shorter sides, is going to be equal to this longer side squared, the hypotenuse squared. is going to be equal to c squared. And then you just solve for c. So 4 squared is the same thing as 4 times 4. That is 16. And 3 squared is the same thing as 3 times 3. So that is 9. And that is going to be equal to c squared. Now what is 16 plus 9? It's 25. So 25 is equal to c squared. And we could take the positive square root of both sides. C, I guess, just if you look at it mathematically, could be negative 5 as well. But we're dealing with distances, so we only care about the positive roots. So you take the principal root of both sides, and you get 5 is equal to c, or the length of the longest side is equal to 5. Now, you could use a Pythagorean theorem if we give you two of the sides to figure out the third side, no matter what the third side is. So let's do another one right over here. Let's say that our triangle looks like, something like, this. And that is our right angle. Let's say that this side over here has length 12. And let's say that this side over here has length 6. And we want to figure out this length right over there. Now, like I said, the first thing you want to do is identify the hypotenuse. And that's going to be the side opposite the right angle. We have the right angle here. You go opposite the right angle. The longest side, the hypotenuse, is right there. So if we think about the Pythagorean theorem, that a squared plus b squared is equal to c squared, 12 you could view as c. This is the hypotenuse. The c squared is the hypotenuse squared. So you could say 12 is equal to c. And then we could set these sides. It doesn't matter whether you call one of them a or one of them b. So let's just call this side right here. Let's say a is equal to 6. And then we say b, this colored b, is equal to question mark. And now we can apply the Pythagorean theorem. A squared, which is 6 squared, plus the unknown b squared, is equal to the hypotenuse squared, is equal to c squared, is equal to 12 squared. And now we can solve for b. And notice the difference here. Now we're not solving for the hypotenuse. We're solving for one of the shorter sides. In the last example, we solved for the hypotenuse. We solved for c. So that's why it's always important to recognize that the a squared plus b squared plus c squared, c is the length of the hypotenuse. Let's just solve for b here. So we get 6 squared is 36 plus b squared is equal to 12 squared, that's 12 times 12, is 144. Now we can subtract 36 from both sides of this equation. Subtract 36, those cancel out. On the left-hand side, we're left with just a b squared is equal to, now 144 minus 36 is what? That is 144 minus 30 is 114. And then you subtract 6 is 108. So this is going to be 108. So that's what b squared is. And now we want to take the principal root, or the positive root, of both sides. And you get b is equal to the square root, the principal root, of 108. Now let's see if we can simplify this a little bit. The square root of 108. And what we could do is we could take the prime factorization of 108 and see how we can simplify this radical. So 108 is the same thing as, let's see, it's the same thing as 2 times 54, which is the same thing as 2 times 27, which is the same thing as 3 times 9. So we have the square root of 108 is the same thing as the square root of 2 times 2 times, well, actually, I'm not done. 9 can be factorized into 3 times 3. So it's 2 times 2 times 3 times 3 times 3. And so we have a couple of perfect squares in here. Let me rewrite it a little bit neater. And this is all an exercise in simplifying radicals that you will bump into a lot while doing the Pythagorean theorem. So it doesn't hurt to do it right here. So this is the same thing as, the square root of 2 times 2 times 3 times 3 times the square root of that last 3 right over there. And this is the same thing. And you wouldn't have to do all of this in your head. Well, all of this on paper, you could do it in your head. What is this? 2 times 2 is 4. 4 times 9, this is 36. This is the square root of 36 times the square root of 3. The principal root of 36 is 6. So this simplifies to 6 square roots of 3. So the length of b, you could write as square root of 108, or you could say it's equal to 6 times the square root of 3. This is 12, this is 6, and the square root of 3, well, this is going to be a 1 point something something, so it's going to be a little bit larger than 6. Say we have a right triangle. So let me draw my right triangle just like that. This is our right triangle. This is the 90-degree angle right here. And we're told that this side's length right here is 14. This side's length right over here is 9. And we're told that this side is a. And we need to find the length of a. So as I mentioned already, this is a right triangle. And we know that if we have a right triangle, we can always figure out, if we know two of the sides, we can always figure out a third side using the Pythagorean theorem. And what the Pythagorean theorem tells us is that the sum of the squares of the shorter sides is going to be equal to the square of the longer side, or the square of the hypotenuse. And if you're not sure about that, you're probably thinking, hey, Sal, how do I know that a is shorter than this side over here? How do I know it's not 15 or 16? And the way to tell is that the longest side in a right triangle, this only applies to a right triangle, is the side opposite the 90-degree angle. And in this case, 14 is opposite the 90 degrees. This 90-degree angle kind of opens into this longest side, the side that we call the hypotenuse. So now that we know that that's the longest side, let me color code it. So this is the longest side. This is one of the shorter sides. And this is the other of the shorter sides. The Pythagorean theorem tells us that the sum of the squares of the shorter sides, so a squared plus 9 squared plus 9 squared, is going to be equal to 14 squared. And it's really important that you realize that it's not 9 squared plus 14 squared is going to be equal to a squared. A squared is one of the shorter sides. The sum of the squares of these two sides are going to be equal to 14 squared, the hypotenuse squared. And from here, we just have to solve for a. So we get a squared plus 81 is equal to 14 squared. And in case we don't know what that is, let's just multiply it out. 14 times 14. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. Stick a 0 there. 1 times 4 is 4. 1 times 1 is 1. 6 plus 0 is 6. 5 plus 4 is 9. Bring down the 1. It's 196. So a squared plus 81 is equal to 14 squared, which is 196. Then we could subtract 81 from both sides of this equation. Let's subtract 81 from both sides. On the left-hand side, we're going to be left with just the a squared. These two guys cancel out. Whole point of subtracting 81. So we're left with a squared is equal to 196 minus 81. 196 minus 81. What is that? See, 190. So that if you just subtract 1, 195. You subtract 80, it'd be 115. If I'm doing that right. Right, it would be 115. And then to solve for a, we just take the square root of both sides, the principal square root, the positive square root of both sides of this equation. So let's do that, because we're dealing with distances. You can't have a negative square root or a negative distance here. And we get a is equal to the square root of 115. A is equal to the square root of 115. And let's see if we can break down 115 any further. So let's see. It's clearly divisible by 5. If you factor it out, it's 5. And then what does it divide? 5 goes into 115 23 times. 23 times. So both of these are prime numbers, so we're done. So you actually can't factor this anymore. So a is just going to be equal to the square root of 115. Now, if you want to get a sense of roughly how large the square root of 115 is, if you think about it, the square root of 100 is equal to 10, and the square root of 121 is equal to 11. So this value right here is going to be someplace in between 10 and 11, which makes sense if you think about it visually.